tell about my project, which is AI-based live video lecture capture and smart notes. Uh, this is the agenda. We are going to see all the topics which is covered in this presentation. Uh, First, the introduction. And then next, we are going to see the statement of the problem. Next, we are going to see the purpose of this project, and we are see the methodology, which is architecture diagram, flow algorithm used, use case diagram, class diagram, implementation, important code segments, output and results, test case, conclusion, future works, and references. Introduction. With the rapid growth of online, hybrid, and recorded classroom learning, live video lectures have become a primary medium for knowledge delivery in modern education. However, students often struggle to capture the complete and accurate information during live session due to the fast-paced teaching and limited notes taking ability. The proposed project AI-based live video lecture capture and smart notes aims to leverage the AI techniques such as automatic speech recognition, which is ASR, and natural language processing (NLP) to transcribe the live lectures in real time. These are the algorithms used in these projects. Next, we are going to see the statement of the problem. Uh, in existing, we have lecture capture and note-taking systems like inability to provide real-time captions and smart notes during fast-paced training or content-heavy lectures, leading to loss of important notes. When a teacher teaches very fast, the students can't be able to take notes properly. It's like that. Difficulty in accurately transcribing lectures involving multiple speakers, varied accents, or classroom noise. If a teacher speaks in a varied accents or a classroom noise or multiple speakers have enabled, uh, then we couldn't be able to get the content properly. Lack of contextual understanding to identify academic terminology, and we have to heavily reliance on manual note taking. We have to take notes manually. Instead of that, our project, the notes will be generated automatically. Next, we are going to see the purpose of the project. The purpose of the project is to develop an AI-based live video capture, accurate, which accurately transcribes lecture speech in real time with minimal latency, adapts dynamically to different speakers, teaching styles and classroom noise, automatically generate structured smart notes for effective learning and revision, displays synchronized caption and notes in real time for classroom. Here, we have to transcribe the lecture speech in real time with minimal latency. Where when the teacher teaches a video, that it records and it gives a summarization of the whole video, and it gives the project overview. Sorry, in the classroom overview, the notes overview. It adapts dynamically to different speakers, teaching styles, and classroom noise. Next, let us see about the methodology. Here we are going to see about the methodology. The methodology is to collect data. Here the data is live audio and video data from the classroom lectures, where teacher's audio has been captured, and the audio and video both are captured, and the online learning platforms like Google Meet, Zoom, Microsoft Teams, and along with that, publicly available education speech data set. Also, we can gather publicly available data sets like Kaggle, etc. And then we have to pre-process the data. We have to clean, normalize, and segment the audio using audio streams, reduce the background noise to make the audio enhanced and used to train easily. Next, we are using speech recognition model. These are the model we are using for real-time transcription. The models are Whisper and Deep Speech. Contextual and natural language processing layer. Applied transformer-based language models. Example, BERT for domain adaptation and contextual correction. And we also the main motto is of the project is to get the captions for the project, and we are use loads latency streaming interface to display captions in real time with urgent speed. Now let us see the architecture diagram flow of the project. Here, the user, the student or the teacher gets into the user interface, our user interface, our website, and they can capture the lecture. They can record the whole video, and that can be audio processed. That audio has been processed to the algorithms which as we are using. That is. Automatic speech recognition. The use of automatic speech recognition is to recognize the speech and it converts into text. Next, we are using text pre-processing. That after using the ASR model, the text has been gathered, and this text has been given to another model, which is NLP, the natural language processing. Its help is to transfer the correct flow of the text, and after that, summarization module. We have summarizing the module, and the smart note output is displayed into the web UI. Design use case. A use case is nothing but a case. The use case diagram is nothing but a graph of actors, set of use cases enclosed by a system boundary, communications associated between the actors and the users, and generalization among use cases. Here, the student record the live captures, upload the video file, browse library, and download and export. The AI agent will give the real-time transcription, generate smart notes, and search and filter. Here, the student can record live capture, live lecture, and that live lecture is this video is gone to the AI engine, and the AI engine gives a real-time transcription. And we have once we upload a video file, that video file is generated to a smart notes. Here is a class diagram. A class diagram is nothing but a representation of an object, and in many ways, it is simply a template from which objects are created. Classes form the main building blocks of an object-oriented application. Lecture, transcript, segment, record page, smart notes. These are the pages we are using. We are going to see the hardware and software selection. The hardware requirements are a minimum requirement is the processor is Intel i3 or AMD Ryzen 3. The basic RAM, that is random access memory, which is 4 GB, and the ROM or storage is 128 GB hard disk drive. Basic webcam to record the lecture. Microphone to the camera is required to record the lecture, and the microphone is to audio to capture the lectures. A stable internet connection, and the software recommended is to OS, which is Windows or Mac, Linux or Mac OS. Let us see the implementation. Lecture capture module. The lecture capture module is responsible for recording live video or audio input during a lecture session. It uses a microphone or webcam to continuously capture the lecture content in real time. The module ensures that the audio stream is clear and the undetected for further processing. This component acts as the input layer of the system where all lecture data is collected and are conventional. Here, all the audio is collected from the lecture, and it is ready for the pre-processing, and it is ready to next ASR module training. Next, we are using speech to text modules. The speech to text modules converts the captured audio into a textual form using speech recognition technology, that is ASR, automatic speech recognition, implemented using Python libraries and application program interface, which is API. This module processes the audio signals by transforming raw lecture audio into a format that can be analyzed and processed further. Next, we are going to see about the text processing module. The text processing module is refined the raw text generated from the speech recognition, and it removes the unnecessary words. Uh, the text processing model defines the raw text generated from the speech recognition. It removes unnecessary noise, unnecessary words, and filter contents and buffer operations such as tokenization. Tokenization is nothing but is a web data mining. Tokenization is a web data mining tool which is used to clear unwanted words and give the necessary words for the thing. And we are implementing NLP, which is natural language processing technique, used to improve quality and the readability of the text. Summarization module. Once the video is uploaded, we have to summarize the content. So the summarization module generates concise, meaningful notes from processed text. Using NLP algorithms, it identifies key points, important sentences, and relevant information from the lecture. The output is a summarized version of the lecture content and making it easier for students to understand and revise. This model is the core intelligence of the system. This is the next user interface model. The user interface model provides an interactive platform for the users to access the system. It is designed as a web-based interface where user can start recording. The user can start recording the lectures and view the generated notes and download them. This is kept simple for everyone to understand. These are the main code segments. We are using speech to text summarization modules. So we are importing in Python. We are importing speech recognition module as SR. From transformer, we are importing the pipeline. First, we are initializing the recognizer. Uh, for that, we are creating a variable called recognizer. In that, we are calling the speech recognition method called recognizer. The next, we are initializing the summarizer. We are creating a variable summarizer. From that, in the transformer, from the pipeline which is imported from the transformers, we are implementing the summarization. First, we are creating a function named capture audio. With that, in the speech recognition, microphone method as creating a source, print recording lecture, audio equal to here we are recording the audio that we are capturing audio from the notes. Next here, in this code, we are using the speech to text audio. We are using a try exception method. In this, we are initializing the text and printing the text, and we are returning the text. If this isn't occurred, we are printing that error in recognition. Next, we are summarizing the text. If the text is more than 50, if the length of the text is more than 50, we have to return the text. We are summarizing the content using the summarizing module from the transformer module. This is the main flow. We are calling all the things, that is we are calling audio, text summary, and finally we are printing. This is the simple web interface. We are using Flask to deploy the code into a web interface. In Python, we use Flask to deploy. So from Flask, we are importing the Flask render template and request. We are sending request through the we are sending request using Flask. Import speak. We are Similarly, we are importing speech recognition as SR. Uh, this is the main code in the Flask program, where app is equal to flask of underscore underscore name. In this code, this code initializes and starts to deploy into a web UI. We are recognizing at uproot is to send the request from the server to the client. At app.root record method equal to post. In Flask, there are four concepts, which is post, put, delete, and get. We are posting the values to the from the microphone to the thing, and if name is equal to main, we have to debug is equal to true. Next, let us see the sample output. This is the sample output. Uh, Sample output. This is the output of project, which is the web UI. You can see that start recording, upload video, view library. In that, we have three buttons. In start recording, we can able to start record the lecture, and after the recording the lecture, we can convert it into thing. And upload video, we can upload the recorded already recorded video into uploaded video, and we can summarize the content. In view library, we can get the past all contents to get and gather. Next, we are going to see the results. Yes. In the results, basically, the system successfully captures a live lecture audio in the real-time processing a microphone or recording voice. The speech-to-text module effective converts the captured audio into a textual format with a good accuracy. The system is capable of generating small summarized notes automatically from the converted text. The generated notes are well structured and easy to understand. These are the results can be expected from our project. Conclusion: the proposed system is innovation, the AI-based solution for capturing live video lectures and generating the real-time captions on smartphones. By using ASR, automatic speech recognition, and NLP, the video text recognition, the system enhances learning accessibilities. These are the future works. The system can be enhanced to support multiple languages. We are thinking for multiple language and multilingual node generation. Uh, these are the reference. Thank you.